Hello and welcome back to the show. My name's Relevant. This is Do All of the Things. On today's episode, I'm going to be installing regulated lighting modules into my Harriman cars. Stay tuned. So if you've been following the comedy, you know I got bitten by that train bug, and I acquired these Harriman cars on the cheap. I put them together, and I had to remount the trucks and do fitting to them and stuff. And a project that I'm now calling the Scrapido Express. I've acquired more cars. For cheap or for free, I got these guys, Rapido Express, Scrapido Express, and then I got these guys, and yeah, they don't match. They're all kind of CN. But they don't match. But I don't care. I run them all together and I like it. So I might be a bit newer to the train hobby, but I am not new to electronics. So when I set up to light these cars, I kind of thought big, like, oh, how am I gonna make the lighting as perfect as possible, or at least perfect within my specifications? Well, I wanted regulation. So let us run you through real quick what that means. We start off with track power. It's DC, but it's no particular phase because, you know, it rotates as you go back and forth. And then from there, we go into a device called a bridge rectifier. You probably have heard of that already because it's common in train lighting because it allows the change of phase on the track to come out the same direction on this side. And that's very important if you're using LEDs because LEDs have a phase. They have a specific positive and negative. If you go backwards, the lights go out. If you want it to be on in both directions, you need the bridge rectifier, especially if you're using a capacitor. That's the next thing on the link. And you might have also heard of these guys because they stop the lights from flickering as you briefly lose power over the track. In this case, I'm using a 2200 UF is what I found by design. 25 volts, I think I got. No, a 16 volt to save power, and because I run a 14 volt system, that's about all I needed. You want to derate your capacitors. You want them to be about 80% to your total capacity, so 16 times 0.8 equals 12.8 volts. So I'm maybe not as well derated as I should be, but it's going to be fine. So normally from here, you might go to the LED. With the resistor to drop the current. But no, I've upped the game. We have something called a voltage regulator, in, out, ground, and then that has a second capacitor. This is just basically a 10 UF because it just has to, you know, support the output of this. And then we have a resistor, current limiting resistor. In this case, it is not going to be the full value you would normally put on an LED. And then boom, we have our LED. Symbol looks roughly like that in electronics. Sometimes they put little squiggly lines like that to represent that it emits light. So what does this guy do? Simply, it regulates voltage. We have a 3 volt regulator. So as long as our input voltage is above a certain voltage threshold, probably like 4 or 5 volts, you need at least a volt more than the regulator is rated for, this guy's gonna put out a constant 3 volts. So as soon as we hit a certain voltage, boom, those lights run at full power and then they stay the exact same. No matter how much voltage we run into here, as long as it's within the maximum threshold, it's going to put a constant 3 volts out. So we can go fast, we can go slow, the light's gonna stay the same. And so here is what it looks like. If you've watched non-train related videos, you've probably noticed I do perf boarding, building custom circuits on these little circuit boards. This is a module that I put inside a passenger car now, and it will give me constant internal lighting. Now, one of the first impressions you're probably getting of this is that it's large. Yeah, this is not the kind of thing like I glaze over my windows in such a way that you can't see really inside the car, but you can still kind of see this. Like you can see a bit of a green blur and a bit of a black blur where the capacitor is. If you're fussy on details, you're not gonna like it. However, I'm not fussy on details. The way I see it, I'm not like, my cars aren't even complete. I don't put the stirrups on because the damn things just break off on me. More trouble than it's worth. My trains I might treat them a little bit more like tools than toys, if you will. That's the reason why I don't have parts on them that break off. Well, I'm not fussy on details. Most of my trains are scrap. I recently bought a bunch of well cars for intermodal. Every single one of them is missing their brake wheel, among other parts. Back to the circuitry, here's the layout. So if you have experience with perf boarding and want to build one of these, well, hey, here's my layout. We have an upper and lower power rail coming from both sides of the board. You can see it will connect to these two little solder pads there on either side. That way we can pull power from either side of the train, or if you have dual power pickup trucks, then boom, you have a spot on both ends to connect them. Those rails go into the bridge rectifier. This red line represents what I call an overland connection. That's basically, we have a piece of wire that has to go over the board because, you know, we would have intersecting here. If you have that intersection, you want to make sure to isolate your pads. I'm not sure if you can see, but I use a little drill bit on just a hand drill. I will cut off that surface pad because these are dual-sided perf boards. This side connects straight through to that side. So if we have wires connecting or crisscrossing like this and we don't scrape off the surface of that pad, I do it on both sides. You'll see there's two scraped off here. You're gonna get a short circuit. From there, the power cubs out the bottom. We have a common negative bus that spans the entirety of the board, and then the positive goes to the 220 UF, the big capacitor, then to the regulator module. Regulator module gets grounded there. The output goes to the 10 UF capacitor. Then it goes to two current limiting resistor positions so that we can have more value to play around with. And then out to the LED with a return bus line that goes and feeds all three LEDs. So these boards are set up to support three LEDs. One on either end and one on the center. And you can kind of configure the board to suit your needs. So for example, this one only has two LEDs. It's going to go into a car like this that has a bias to one side. So I'm going to be worried more about lighting up here, not so much there. It'll be a bit darker there, but that's okay. Especially in, say, a combo car like this that just has baggage area. I don't expect that to be as well lit as the passenger area, so yeah. Also, the mod that I did to these cars is I've got some power trucks on them, ready to go, but I only have one. Because of how effectively this module works, I only need one power pickup truck, and that also saves money. I can buy a pair of trucks and boom, outfit two cars. For that reason, I only have power pickup on the one side, not the other side. I didn't bother in this particular board putting the bar that goes all the way across. That said, if you're only going to have single power pickup, you want that to be on this side close to the bridge rectifier so you don't have to worry about building these lines. And if you're going to have LEDs biased to one side like this module, you're going to want the LED to be on this end. So power in this end, light on this end, because there's a big specialty line that has to go all the way just to connect this LED. We can omit that if we only need to light one side. Now for the current drop resistor, I'm using a 10 ohm to run these two LEDs. I have the option to put a second one in there to make it 5 ohm. 10 ohm mostly because that's what I have in stock. On the 3 LED system, I'm actually using two 10 ohms, so it's getting 5 ohms to let a little bit more current through because there's more LEDs. The LEDs I'm using are rated for up to 3.2 volts, and the regulator regulates to 3 volts. I could run these raw without that current resistor, but then you have 3 really bright LEDs. The entire system starts consuming about 90 milliamps. The regulator is only rated for 100. It starts to get hot. One of the reasons why I did this. Also, we're going more for distributed light. We don't need these to be maximum bright. We need them just to be reasonably bright, and we ideally want, you know, them to be less bright each and just distribute the light evenly as opposed to like a couple single bright harsh sources. We locate the LEDs as high up on the board as possible because we don't want the LEDs in the periphery. We don't want to be able to see them through the window when we're looking at them. If they're too low, that's a problem. On one prototype on one of my other cars, that's what happened. I put the center one low and it looks dumb and I either need to go in and change it or just get over it. So what we do is we blast them right into the ceiling because we're going to add diffusion and reflection to the ceiling. The idea is The LED is going to blast at a diffused reflector that is on the inside of the top of the car, and then that's going to rain the ambient light down inside the car. So what are all these parts? The bridge rectifier is a Vishay B380C800DM E345. Oh yeah, that's a mouthful. Basically, it was the cheapest bridge rectifier I could get with the lowest voltage drop. Your typical diode is going to steal 0.7 volts away from your circuit. We want maximum voltage to hit that regulator so that it regulates effectively at our lowest speeds. A bridge rectifier, the way it works, your power is actually going through two diodes, so they'll drop like 1.4 volts before the circuit gets the power. The voltage regulator, Texas Instruments LP2950, and then we have 30 LP blah blah blah, key term 30. If you put in 2950, you'll get a variety of them, but it's a 3-volt regulator, rated for 100 milliamps at the most, but it's also known to be a low dropout regulator. That means you don't need as much of an overvoltage threshold to activate it. Remember, in order to get 3 volts out of this, you need about 4 or 5 volts in before it starts to regulate properly. Otherwise, if you put in 4 volts, you might only get 2 volts out. The LEDs will work, but they'll be dimmer. So you'll notice as you're starting up your engine, it will be a little bit dim at first, but then it'll hit the threshold fast. It might even blink on and off because you're triggering that low voltage dropout. Capacitor's pretty standard. I like these Rubicons. Okay, it's a 2000 hour at 105C. No big deal. Again, I went with price. And then the 10 UF is a Worth Electronic. Okay, just look at that. I'm not going to read it. And again, I'm using 10 ohm resistors on here. That's pretty straightforward. If you're shopping on this website, go to products, passives, resistors, through-hole resistors, in stock, exclude, apply, figure out what ohmage you want, in this case 10 ohms, roughly a quarter watt, and then boom, sort by price, go nuts. You just want to double check the data sheets to see what size they are, because they're not all same physical size. If you're using this layout, you want ones that come in about the 1/4 inch standard size. I believe that's 6.3 millimeters long. You also want to mind your dissipation. Yeah, at 10 ohms, you don't have to worry about dissipation that much. And then finally, the LEDs. Now, even if you don't want to do this perforaboardy dealy, these are LEDs I highly recommend for HO lighting. They're this guy, Everlight. Let's choke on this one, 334-15/X1C3-1TVA. Hoya, bud. And what's special about this guy? 3.2 volt rating, 20 milliamps. It's one of the brightest 5 mils in a warm white, which means when these puppers light up, they don't have that harsh color to them. I got a Walthers train line recently. It looks yellowish. Ugh. A lot of LEDs are very white or they're even bluish. You're not sure what you're getting, but these guys are a warm white. They are going to be whiter than the incandescent bulbs you might be replacing in, say, a locomotive. But as you can see, they're not whitish and ugly. They look like a good halogen bulb cranked balls out. Like if you saw a train in real life with their old big frickin' par bulbs and it was cranking all that voltage into it, it's gonna look like that color is gonna be pretty accurate. And here's the thing you're gonna notice. Because of the way this is filtered with that capacitor, and this is the reason why we only need the one power pickup, is we can disconnect power to it for a pretty not insignificant amount of time and it stays pretty much consistent. Especially helpful, that one only has 2 LEDs. It's obviously not going to be as good on one with 3 LEDs. Oh, it's still pretty good with 3 LEDs. 33 milliamps, that was my target. I wanted about 3 LEDs at 10 milliamps each, which is half their theoretical brightness. Wanted to distribute that light nicely. Now you might be thinking, oh, well that perf boarding, that's pretty fancy. That's not of much use to me. I don't have the tools and whatnot to do that. Yeah, that is a thing that exists. You might not find this design or this way of doing things very useful. I'm not making a video of me building these modules because you either know how to perf board or you don't, and you either follow the channel and have seen me do other perf boarding sessions or you haven't. I guess if you want that benefit, you're just gonna have to go watch more videos of mine. If you are going to get into perf boarding, well, here's the certain tools that I use. As mentioned, I got the hand drill. Obviously, you have needle noses and tweezers. I have a stray alligator clip that I use to maybe hold a piece of wire into place or down while I tack on it. One of my most secret weapons is this pin tool. It's literally just a pin on a stick. It came out of an old microscope kit, and you can put that into a hole, and that will allow you to do a hard bend of a lead. My soldering iron is a Weller WP35. That's a fine tip. It's only this that I use the fine tip for. And I have a Heiko 599. That cleans your tip. Those sponges actually aren't very good. The solder I use is this SRA. It's a 6437 blend, 0.031 diameter rosin core. It is a nice leaded fine solder. And then we have one of these, our little side cutting shears. Other than that, the only other thing worth mentioning is this spool, 24 gauge tinned copper wire. And this is what I use to make the traces on the perf board. Unfortunately, this is where things get hardcore because this is like $60, $70, $80 a spool because you can only get it in 100-foot lengths. So lasts you a frick of a long time. I'm not gonna need more of this for a while. If you do a lot of perf boarding like I do, this is a necessary investment to be able to build those traces. Otherwise, you can, do it by bending the component leads over and weaving them together. In some cases, parts that you trim off one spot, you can put somewhere else, or, just get yourself some cheap solid copper wire, strip it down, use that. That said, let's get to the fun part now. Let's actually install this into the train. So let's start with one of these guys, right, bud? Because they take this offset module that I built. I think that offset module will accommodate this one quite nicely. This one might need a little bit of modification, maybe just a little bit of an aim. I don't plan on building the module any differently for this guy. Screw it, we'll stick it in this one for now. Diner car. So I don't glue my guys together so that I can service them. So that comes right off. I've already treated the windows. I got the plastic that it comes with on there and some just Scotch tape to glaze them over. I put proper copper Kadley. I put proper Kadee coupler boxes on here now. All these cars have Kadees on them. I drilled them, tapped them. I got the 2x56 drill and tap kit and 2x56 plastic screws they have. They stick up a little bit, but again, that's a detail you're going to miss at 60 miles an hour. I shimmed the trucks because I found they didn't rotate nice. And I did that by drilling the truck hole out with a 440 tap. And I use 440 screws typically to mount trucks these days. And on here is an already truck upgrade, a powered truck ready to go. It's the Rapido Bits SKU 10 2001. It is the 41 BNO11 outside swing hanger truck. Basically the cheapest truck I could acquire locally of good quality and power pickup. So you get a truck like this, it's got the steel wheels, it has two tiny little wires on it, and outside swing hanger apparently was some sort of upgraded. The inside swing hanger ones were apparently the ones these replaced. They do the job for me. I'm sure my passengers can't feel the difference in my swing hangers. To mount these guys, 2 stainless steel washers and the nylon nut go on there, and then they just thread into there. And then because that's threaded, once we tighten that nut up against the base, it locks the screw into place. Now, because I didn't glue stuff together, this comes right off, which is important because we actually need to start off by figuring on where this is gonna go. So the lights need to shine on this side, so power truck's gonna be on this side. So we're gonna put a hole, I put it like right here. Start off with our hand drill to get the hole that we want through there. Don't need a very big hole. Now that that's through, I'm hoping it scored that plate. The wire's got to go through this metal. We don't want the wire to touch the metal. So we just get an oversized hole in there. We don't have to worry about it. That thing is just hot glued on there. So chances are if I warm it up just a little bit, it'll pop right off. I use the glue sparingly if I can. Fortunately, this is reasonably mild steel, so it drills pretty easily. Don't forget to chamfer and deburr this tool in the plumbing section. I do not know why these aren't more popular. I can't live without these. This is warm enough from the drilling action. I bet if we push it down on that glue, it'll re-stick. No, but if we do one of these, Now that that's done, if we just slip that back on there, we can drill the rest of the way through. So now we have a tiny hole for the wires to pass, but a large hole in the metal so that those wires can't touch the steel. Now I can pretty much put this back together. Got the passive stock truck, and here's the non-passive, the active truck. We're just going to get these little wires through that hole. Now we'll leave those trucks tight for now while we work on the rest of it, because now it's actually pretty freaking simple. These wires are so small they strip with just your fingernails. In fact, I don't think I have a tool that can more accurately strip these without burning them out, damaging the wire. Let's give them a quick tinning. So I kind of want to figure out where center is going to sit, where we want it to sit, make sure the wires can reach where we want it to sit, yes. And I'm kind of going central to the windows. These guys aim pretty much straight up. So I think that should do. And once I've estimated, I'm just going to kind of draw a quick reference outline here so I don't have to figure this out while the glue's hot. And then of course for glue, my preferred libation is just, your hot snot. Put a dollop there, put a dollop there, and mash it down. Yeah, stringies. That's what I don't like about these. It's like you use a glue gun and all of a sudden it's like, what? Is a spider going nuts in here? It's like spider webs everywhere. Now, once that's hardened up, our contact pads, give them a tinning. And because of the bridge rectifier, it doesn't particularly matter what wire connects to what contact. It's all gonna get sorted out in post. Tack the wire on and tack the other wire on. Now, if we throw it on a piece of powered track, we should get light. Yeah! Yeah! So, as is mentioned with the diffusion, now we move on to the roof. So what do we do with the roof? Well, we have this foil tape that you get from the hardware store. We cut a piece that is, the inner length. We don't want it to go right to the edges, especially if you have things on the edge like we do here. And then we cut it in half this way. We end up with a strip like this. Got to kind of hold her flat down and peel her back so it doesn't curl too much. Kind of give her a taco fold like this. And get it on there. Get it on there. And it doesn't have to look pretty. You're definitely not seeing these details. Just gotta squish them into place. So now we have a reflector. These guys are gonna blast up at the reflector and that light's gonna rain down. Not quite done yet though, because we need some extra diffusion so that those reflections aren't harsh. For that, my go-to is parchment paper. Parchment paper is temperature rated, so I will use it in certain electronic applications and lighting applications, even though we're not expecting a whole heck of a lot of temperature with this. So right up above where these lights are blasting, that said, this didn't have to be a whole strip of silver. Just gonna kind of tape on that now, even though you gotta watch out, sellotape, scotch tape, whatever, doesn't stick to parchment paper well. So the technique is you gotta it's kind of pinning it down on the corners, right? So it sticks to that well, and then it just can't lift off. Sticks some to the edges here too. You essentially end up with latches that just hold the paper down. And there you go. You've got a diffusion layer. So these LEDs, which are higher than the window line, are gonna blast against that diffusion layer. Let's just get the bulkheads back into place and let us put a lid on it. Haha, car, yes. Now when we give it some power. So the first thing you're gonna notice is that doesn't look particularly bright, and you'd be correct. But that's because we're under some quite bright studio lighting. Now you probably see more of the effect you're gonna get. Again, it's not designed to be super bright. It's just designed to fill the car with some nice diffused lighting. And you're gonna notice maybe it shows up on the camera. You can see a bit of green. You can see a touch of black and red, the components that are on the board. And I guess maybe we have a dead spot here. I don't know what that's supposed to be, the kitchen. Maybe we want that to be brighter than everything else. If I really want to, I can tap power off the board at another time and stick an LED over here. Maybe I should have the second 10 ohm on there so that brightens up a bit. I don't know. I won't know until I throw it on the track with the consist and see how it compares. As you can imagine, there's a little bit of fine tuning involved. Only thing left to do now is fine tune the trucks. So not only do we want it to be able to rotate freely, but it has to have a little bit of weeble wobble like that, which helps it prevent it from jumping track. Same with this guy. Yeah, that should be good. Next up on the chopping block for installation, because I have two of these modules currently constructed, is this guy, the XCP. I already have the Rapido trucks mounted on here. The trucks it came with were kind of crap. Some of these cars, like these guys here, these trucks are actually decent, even though they're very old. They've got a good, healthy, free spin. They already pick up power. These ones picked up power, but they just weren't good trucks. They jump track a lot. So the Rapidos are already on there. These guys just kind of pry open. They're supposed to have a screw to fasten them, but it seems unnecessary. Now this guy's lit already. It has the stock lighting in it. So it had some set up with like bushings, power bushings here. I just soldered the Rapido trucks onto the light fixture, one on each side. There is power to the base for that reason, but these guys are getting eliminated today. Or, you know, we can go ahead and leave them there. They're not going to get in the way. So now we need that onto there. And because this is metal, we are going to put something down first. Guess I'll just use some of my go-to hockey tape, the Canadian Handyman's secret weapon. That'll stick there well enough, and I'm sure we can glue to it. I don't put a lot of blob because if I have to take this off after, it's going to be a little bit easier if I don't. Get it roughly. There we go. So it's essentially taped down now. The wild card here, why I wanted to show you this, is because this is dual powered trucks. We have to make sure we get our track polarity correct. So we have to figure out what wire is what, and they're roughly correct now. So these wires are for the wheels on these side. You know, these are linked together here, so if we cross these wires, we're gonna get a direct short circuit. So let's freshen up this tinning and get that ready to go. And tack those wires down. So this is gonna be solid because it's gonna have 4-wheel pickup. This has more power pickup than a cheap locomotive. Now, the astute among you are gonna notice I have wires going through metal holes. Yeah, I wish I had little grommets or something. Maybe if I knew I didn't have to worry about slack, I could put a bit of glue. I'm not sure. I just figured if I made the holes big enough and I chamfered them smooth enough, it's not going to be a problem, or at least it won't be a problem today. Maybe it'll be a problem later on. But right now, as it stands, the frame here is electrically isolated now. So we don't have to necessarily worry as much about short circuits as we did before. Let's put it on this test piece of track, and that means we got our polarity correct. So we have to do our treatment to this guy now. For that, we're gonna acquire some single-use plastic and give it a double use. You buy the salads at the grocery store, the pre-made salads. Needed something relatively clear, and that was gonna have enough size to it. This is a surprisingly clear piece of plastic. Oh my, it's just long enough to get all these windows here. Ho, 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 boy. Yeah, just. I got lucky with this one, man. And as classic part of our treatment, we throw down some Scotch tape. Now we gotta get that on there. Oh boy, I did not do that right nice. There are all sorts of bubbles and flaws. Oh, how did I do this before so nice? I think I put the plastic piece down first. Yeah, like this, okay. Basically sticking it to the table. Probably should clean the table before you do this. Now we have an adequately obscured section here, except we still have a door hole, and I guess I won't fuss over these tiny little end holes. Always goes much faster the second time after you get your strategy down, right bud? Okay, so I kind of managed to get windows on those two little holes there, but probably not gonna bother with that one. Either way, we've reached our target. Now we have to put in our diffusion and reflection. All right, this guy's flatter, so that should just go. And our diffusion. Wait, she's slipping on me. All right, that should do it. Okay, now I might spread these just a little, just so they kind of encompass everything. And now let's get this into place. And let's see how this looks now. Oh yeah, I think this one turned out nice. That's gonna look nice rolling down the track, bud. Oh yeah, def. So I need to build like 6 of these in total. I have provisions to make 10, not all with 3 LEDs. Some of these are only getting like 1 LED, like the bitter baggage car, probably just 1 LED in the center. This one would get 2 LEDs on either edge. This one, probably 2 LEDs. These guys, they don't get the same treatment. Now this particular car is interesting. because it has a tail light and it's in there, and I do believe it's already an LED someone put in there, red. These things came with these blue domes in them. I believe someone put these in there. I don't think they were factory. I don't know. Not sure if you can make that out, but it's kind of like, it's like the color of my walls. It's like a seafoam green, but it needs to be a touch brighter. So I'm still sorting on these cars, and yeah. Sorry for the dedicated hand view. I just lost a camera. Not gonna bother changing the battery because we are done here. As mentioned, I gotta build another few of these things. I'm gonna go ahead and finish the rest of these cars, and then we will go and we will roll that beautiful train footage.